Okay, so we will start our discussion on data warehousing, and online analytical processing. In this chapter, there's lots of concepts that need to be described or explained. This chapter 4 is an overview of data warehousing and how to construct it, and what kind of analytical task it supports. Chapter 5 is a more focused discussion on the algorithms in terms of how to materialize data cuboids to make data online analytical processing more efficient. We are not going to cover chapter 4. We are going to cover chapter 4, but not chapter 5. And you can, if you're interested in the implementation details, you can actually read chapter 5 on your own. As always, we have a set of learning objectives. As you can tell, this chapter we have lots of definitions and contrasts among different concepts. So make sure that you know what those acronyms stands for and what those concepts are similar or different in certain ways. If you could actually comfortably expand those concepts, then you have a very good overview of the data warehouse and data warehousing concepts. So, what is a data warehouse? As many other terms, many terms are defined, are used and sometimes loosely used in different contexts. So it's the concept of data warehousing has been used loosely in many different scenarios. But in general, we know that a data warehousing is a database that is maintained separately from the organization's operational database. So what is an operational database? If you are shopping online, if you're booking your airline tickets, you are interacting with the back-end database that the company maintains. And this database supports day-to-day transactions. This is the company's operational database. And data warehouse is something that's separate. It's a database structure, but it's separately maintained from the operational database. We will talk about why they need to be separate shortly. All data warehouse supports information processing by providing a solid platform for consolidated historical data for analysis. So the reason, this also already hinted on the reason that data warehouse need to be separate from the organization's operational database, because I should here use the noun form of data warehouse. So data warehouses host consolidated, aggregated historical data. So it's not day to day. It's like in the past quarter, in the past year, in the past 5 years, aggregated data to support for decision making. Okay. Emon has proposed a data warehousing definition, which is becomes a well-respected definition. So it emphasizes a number of special dimensions of a data warehouse, which is subject-oriented, integrated, time-variant, and non-volatile. So the collection of data in a data warehouse has those 4 features, and we are going to talk about those four features separately in the following slides. And now I want to introduce the verb form of data warehousing. Data warehousing refers to the process of constructing and using data warehouses. So data warehouse has this feature, it's subject-oriented. This also explains why data warehouse has to be separate from the day-to-day operation. The day-to-day operational database must support all aspects of the company. But data warehouse, because it needs to support decision making, therefore it's organized around major subjects. For marketing and customer relations, you will have a data warehouse focused on customer. A component within this data warehouse would be a data cube for customer. You could have a data cube for product, for sales, for the major areas that the business concerns. The data in the data warehouse will be organized based on the subjects to support decision making. So in the process, we collect anything that's relevant to customers, but exclude things that's not relevant, so that the operation such as drill down and roll up will give meaningful information to decision makers. So that's the subject-oriented characteristic of data warehouse. Secondly, data warehouse holds integrated data. Data warehouse are constructed by integrating multiple heterogeneous data sources. Large portion of data warehouse host relational databases. Those could be aggregated data from operational databases, but it could also extract information from flat files, online transaction records. So anything that's supporting certain decision-making goals will be aggregated in the data warehouse. Therefore, data warehouse has substantial data cleaning and data integration needs, and those techniques that we have discussed earlier will be applied. For example, maintain the consistency in the naming, encoding, attribute measures, units, and all that. So the data, when they move into the data warehouse, they go through this data transformation and cleaning process. When the data gets into the data warehouse, the data are already cleaned and are ready to be integrated and analyzed along with all the other pieces of data in the data warehouse. Data warehouse is also time variant. Time variant means that at different times when you analyze the data in the data warehouse, you might get different results. This is because data warehouse are regularly refreshed. The data is initially loaded and transformed into the data warehouse and then periodically refreshed. Because data warehouse hosts historical data, aggregated historical data, therefore the time line for data warehouse is significantly longer than any of the operational systems. For example, past 5 years to 10 years. Operational database host current values, right? And a data warehouse has aggregated information, and it's periodically refreshed. So because of this, the historical perspective, any element of the data warehouse, you can see it's implicitly or explicitly referenced to a time frame. In contrast, operational data is providing current view, therefore it may or may not have this time element. The third characteristic of data warehouse is, I think that's the fourth one. The fourth characteristic is non-volatile. This says data warehouse is physically, it's data physically stored in a physical medium. It's transformed from the operational environment, but it does not disappear. It's physically stored somewhere. Another key point that we want to mention, because of the historical aggregated nature of the data in data warehouse, the operations typically happen in a data warehouse include only two operations. Basically, it's the loading and the access of the data. We have initial loading and the continuous refreshing. And then the data will not be changed in between of those initial loading and refreshing steps. And in between, the only operation that's going to happen in a data warehouse is access of data, which supports online analytical processing and maybe online mining applications. So it does not require transactional processing, concurrent control. For example, students has database background, you will see the difference that because that we don't have concurrent write or concurrent modification to the data storage. We don't actually need all those complex transactional database maintenance mechanisms. The only thing that really happens in terms of the maintenance warehouse is initial loading, refreshing, and then the entire other access is going to be operating, read the data and generate insights. We mentioned throughout the slides the operational and data warehouse differences. And here we want to contrast operational database supports online transaction processing, where data warehouse are mainly used to support online analytical processing. So we're going to use this table to contrast the differences. So the online transaction processings, the user of those are the clerk, the IT professionals. For example, your store clerk that helps the customer. They directly interact with operational database, checking out an item, change price, and all that. The function of transaction is to support day-to-day operations. Database design is focused on application-oriented, make sure it's usable, it's accurately update data, controls concurrent access to make sure the data is always consistent over time. The data stored in those to support online transaction processing needs to be current, up to date. Of course, you want you don't want outdated price to be in your database that's going to mess up with your entire customer service. And the usage is repetitive. You can imagine how many clerks are checking out items for people, and their use they're used all the time. Access, you have read and write access. You need to index and hash on primary keys so that the access will be fast, efficient. You might change price. For example, you have promotion items that have price needs to be changed systematically for certain items meets criteria. So you do actually support write and read access at the same time. Unit of work are often short and simple transactions, adding, checking out an item, invoice, processing inventory, and adding change price. And those does not take a long time. It's short and simple transactions mostly. Number of records accessed at one time. In a relational database, you have tables separated. Those tables are related to other tables. But total number of records that's touched by those online transactional processings are in the rank of tens. But number of users could be a lot, in the number of thousands concurrent access. And database size is often within megabytes. And the metrics to evaluate the efficiency of the system, we count number of transactions within a certain time limit, how many transactions we can support concurrently. In contrast, the online analytical process, as we mentioned earlier, the goal of data warehouse is to support decision making at higher level of the company, need to make strategic decisions. So the user of data warehouse are knowledge workers, data analysts, and store managers, CEOs, for example. The function is to support decision, and the database design, as we mentioned, it's subject oriented. So the data is organized with around a major subject that supports certain kind of decision. Data are historical, summarized, aggregated, multi-dimensional data, and we're going to look at how the data is organized in a multi-dimensional sense this in the following slides. The usage is ad hoc. You don't have a pattern. You don't know what kind of queries the knowledge worker want to issue. Therefore, the data warehouse needs to support ad hoc queries and make them efficient. Much of the chapter 5 is talking about how to make those efficient. Access, it requires lots of scans, scanning the database to collect all the relevant information to support decision making. As we mentioned, since the queries are ad hoc, we cannot predict what table going to be accessed. Therefore, we have lots of scans to gather necessary information. We support complex to query and the serious query. We cannot predict how many queries the user would issue. Numbers of records accessed could be in millions, but the number of users is going to be smaller. Only people need to support decision making going to access data warehouse. Database size, terabytes, easily terabytes. Metrics, it's the query through output, but also the response. Can the OLAP processing provides insights from the data and present those insights in an intuitive way. So as you can see, those two are quite different, supporting different aspects of a business. The online transaction processing supports day-to-day operation, where OLAP, online analytical processing, supports decision making. So this, given all the information that we discussed, I think by this time we should have an understanding and that we can see that in addition to the operational databases, a separate data warehouse is needed. Because typically database management systems, for example, Oracle and other relational database systems, they're tuned for OLAP, online processing, online transaction processing. They have full support for access methods, indexing, concurrent control, recovery mechanism, but data warehouse need less of those, more of the other, supporting complex queries over aggregated data. Therefore, the mechanism that implements data warehouse is quite different from relational database that's tuned for online transaction support. The data, the aggregated data, historical data needed to support OLAP operations are typically not maintained in online transaction data, because online transaction needs to support immediate response. It makes no sense to store data that will not be used at this moment. Therefore, those historical data are saved somewhere else, which should be in a data warehouse. And data warehouse also has those consider consolidation needs. We talk about heterogeneous sources, data integration part of it to support decision making. And the transformation, we need fairly complex to data cleaning and data transformation processes to get clean data into data warehouse and integrate data from multiple sources. So this, having said that, conceptually those are very are quite significantly different operations, needs different data to support different functions. They are more and more systems because the OLAP operation has been valued in business intelligence. Therefore, more and more database systems also support OLAP analysis directly on relational database.